Good morning and good evening, friends. Welcome to goonlinetrainings.com. So we're done with the couple of sessions on data engineering using Azure. So entire world is using Azure. So data engineering means I strongly recommend to go into Azure, even though you go and try to learn AWS or GCP, same concepts are going to be repeated. For the data storing, we may use Azure SQL, Azure Data Lake here. So there also we have data lake and AWS SQL. And for the orchestrating and ingesting the data, we must use one ETL tool in Azure, that will be Data Factory. If you take AWS, it will be Glue. AWS Glue will be the ETL tool there. And in Azure, we're going to be using Databricks for the transforming the data and processing the data. In AWS, we have AWS Databricks with PySpark and Spark SQL. So, there also same concept is going to come. So if you learn any tool, whether it is Azure or AWS, so 90% of the content is similar or the same. So only 10% of the content will be the look and feel of Azure and look and feel of AWS or GCP. That will be changing here and there. So you should not be worried about it because same data bricks here and there, the same ETL concepts here and there. Some data lake will be in Azure. In AWS, S3 buckets to store your data. What is S3? It is a data lake again. What is the data lake? It is a distributed architecture, distributed file processing system. You can store unlimited data into the S3 buckets or in data lake. So all these things we have discussed. So you should not be worried about it. Now, recently, Microsoft is introducing Microsoft Fabric. So Microsoft Fabric is going to be used all the services in single umbrella. So that is what is called Microsoft Fabric. So if the time permits, I'll be talking about that as well. But I wanted to continue today with the different concepts. Now, let us understand what is OLTP and what is OLAP. Already, we know what is a data warehouse, but today let us talk about what is a data lake and or a delta lake. And if the term permits, I'll be talking about Hadoop daemons, right? So if you wanted to understand the Spark architecture, Spark cluster, you have to start with the Hadoop to store large amount of data. Then later on, companies are started using Spark clusters. So we need to understand Hadoop architecture first, then we'll be jumping into your the Spark clusters and everything. So couple of days we'll be having theoretical classes. After that, we're going to talk about the practical things. Okay, so meanwhile, you must watch my Python videos. So one by one, at least the basic fundas: how to declare a variable, how to do the printing, how to perform the looping, what is an array, what is a list, right? So all these things, if you know, that will be more than sufficient for you to understand the PySpark code. Chal. Now, we've spoken about medallion architecture. When you ingest the data, all the data will be coming into the landing. From after that, we're going to be moving the data to the different folders. All of them are folders in the data lake. Landing, bronze, silver, gold. All of them are the folders within the data lake. Now, the medallion architecture is very important. Now, I wanted to tell you what is OLTP, online transaction processing, and what is OLAP. What is OLTP or what is OLAP? So both of them are, two different databases. So who has given this? So this is given by Dr. E.F. Cod. So Dr. E.F. Cod, who is this guy? Who invented your SQL, right? So he said, according to him, the databases are two types. Databases are two types. Okay. When we refer OLTP, what it is? It is online transaction processing, according to Dr. E.F. Cod, who invented SQL, right? In 1970. He has invented lot of code rules, right? If we have, he has invented total 13 code rules, and out of 13 code rules, If you have minimum 9 to 10 card rules, if you have it in that any DBMS, that is called as a RDBMS, right? Minimum, if you implement 9 or greater than 9 card rules, if you implement any database management tool, that is RDBMS. If you have a lesser than 9 card rules, it is simply database management system. So such is called MS Access. Released by Microsoft, which is a purely database management system because it did not implement more than 9 rules. Don't ask me what is a rules and everything. You can just go and look into the Google. But if you take Microsoft SQL Server or Oracle or DB2, all of them are implemented more than 9 rules, right? So these are called RDBMS. This is simply still database management. It is also from Microsoft. This is also from Microsoft. It is database management system. That is today relational database management system. Clear? So according to Dr. Cord, whether it is OLTP or OLAP, both of them are databases. So what? It is a database only. Means it is going to store your data. Remember, but it is going to be having a small size database. Right? OLTP, somebody says we can give abbreviation. OLTP means online transaction processing. According to EF code, OLTP refers to a database. So the database, is going to be storing a transactional data. Clear? So daily transactional data, and according to him, it has data, more read and write data, but 80% of the time it should be capable of taking more writing capabilities, right? And if you wanted to implement more writing capability, you have to create small tables in this, and it has to store lot of data, right? So all the data, maybe customer data, maybe sales data, maybe orders data, category data, this data, that data, all the tables are going to be created here, and many tables we are going to be creating inside OLTP databases. And this kind of a thing is called as a normalization. Clear? Splitting the data, storing the data into small tables is called as a normalization. How do you design OLTP databases? If you want to design OLTP databases, there is a designing concept called ERD modeling, entity relationship diagram, right? So if you wanted to construct a house, piece of land is available, do you construct directly, or you go to the architect and you give the requirement to the architect? Then architect is going to be designing a document and giving it to you. Based on the document, you're going to be constructing your house. Now, I wanted to store my data. For example, I'm developing a loan application. So I'll give my requirements. So to whom? To the data architect. Complete requirements is going to be creating a ERD modeling, entity relationship diagram. Using that design document will come. ERD is a document, and this nothing, right? It may be Oracle, you may be using tomorrow, SQL Server, you may be using tomorrow. ERD is tool independent concept. So before starting database designing and inserting the data into it, you have to create a ERD modeling. ERD modeling means you need to understand. So we are designing OLTP databases. OLTP databases means online transaction processing, which is going to be connecting to the end user, receiving the end users data directly. For example, you go to phone pay application, or you go to a State Bank of India application online, or you may be using yatra.com, bookmyshow.com, irctc.com, or you go to Muthoot and pay interest to the gold loans, or every month EMIs you're paying, you're paying. All these applications are receiving the data from the customers directly into their databases. So all these applications, maybe Java, maybe .NET, maybe PhonePe, maybe Android application, right? Amazon, maybe Android or Java application. But all these applications are made up of using a languages like Java.NET. But we knew Java.NET cannot store the data. All these applications are going to be storing the data into the databases. End of the day, phone pay applications data, Google Pay applications data, Amazon data, Flipkart data, Walmart data, State Bank of India data has to come to OLTP databases only. Clear? So end users are going to be connected with the data, to the phone pay application. Phone pay is going to be storing the OLTP refers to database. It may be Oracle database or maybe SQL Server database. Doesn't database will be very, very small, maybe in GBs. Am I clear? If somebody tells you this is what. So who invented, who categorized the in 70s he told, so these are the databases we need to have it. So all the transactions data, whenever you do pay EMI to the bank, that is a transaction. Whenever you withdraw the cash, that is a transaction. Whenever you do the funds a transfer in a phone pay, that is a transaction. Whenever you cancel a cinema ticket or a movie ticket or air ticket, that is a transaction. Whenever you book a ticket, that is a transaction. So whatever you do in the real world, so all of them are called transactions. Transactions will be transactional data is going to be stored. So OLTP applications are completely used by end users. Clear? You are going to be so much of a data. So in these applications, writing a capability has to be more and more. If you wanted to increase the writing capability more, you have to create a small tables more and more, right? So you can store all the data into single table. That is a big query concept or single table concept. So when you create a single table, store all the data, the writing capability will be very, very slow. Remember this. You can have for everything one table you can create and store. There is no problem at all. For example, you join, say, you come to goonlinetrainings.com, you give your number, you ask for the course, then we write the course name also, then you make the payment, we write the payment details. So all the data I'm going to be storing in a single Excel sheet, that is also fine. But when you have a slow more and more data, when you're getting it, and all the data if you're going to store in a single table, it will become slow. So the single table will be distributed. One is called student table, one is called a course table, one is called enrollments or the admissions or the payments table, one is called different categories of courses, and sales table, marketing table. So one table data we are going to be dividing into multiple tables. This is what is called normalization. Clear? Normalization is going to be removing redundancy. That is a theoretical concept. Why normalization means, instead of storing the data in a single table, I wanted to split the data into multiple tables. Clear? Why? Normalization improves writing capability. How? We're going to be learning a special concept in data warehousing videos. So I'll be talking about what is OLTP, what is OLAP. Once again, you must watch those 10 hours of data warehousing. But as of now, we should know OLTP refers to database, and this categorization given by Dr. E.F. Cord. So OLTP databases are small in size, maybe gigabyte of data it's going to be having. So all the customers are connected to these applications, and here we are going to be using OLTP databases to run my business. To run my business, we're going to be using these databases. For example, if you go to State Bank of India, that is OLTP application, right? If you use phone pay, that is OLTP application. So whatever be the application that you're using it today, maybe Java, .NET, Android or X, Y, Z, SAP, any application that you use as an end user, that will be OLTP application. OLTP designed such a way that it has to take more and more orders. If you go to Amazon.in, if you wanted to book a lot of offers, for example, now let us think about Diwali is going on, or Christmas is going on, or Sankranti is going on. You will have more and more people are buying and buying, buying and buying, buying and buying. So that Amazon data, Amazon application should be created keeping in mind that people should not be getting any kind of a slowness, or data, the application should not be, having a delay issues or, latency issues. If that is the application, if you're implementing, definitely you lose the Instagram. One video is taking 2 minutes of time. Do you think that people will be there in Instagram more than 2 minutes? They'll simply switch to YouTube. If the YouTube is taking one video is buffering and loading so much of a time, at least it is taking another 2 minutes of time. Do you think that people will be there in, YouTube? No, immediately they'll switch to another, social media. Why? Because even though you create a super duper application with the latest technology, if it is not, performing properly, then people are going to hate your application, right? So special teams are going to be working. No video than 10 milliseconds, it has to load. Clear? So the buffering should not be there. So it has to be very, very fast. Whenever you buy any product, whenever you view something, all the data has to be recorded into the OLTP databases. OLTP databases always, small in size, because they have to respond a lot to the customers. If the big in size, for example, if you're a fat guy, do you think that you can run quickly? No, 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 right? You have to have a thin guys can, walk faster and walk, quickly. So OLTP databases knowingly less amount of data. When the data is full, 1 month, 2 months, 3 months of data is already there. If this is full, what they do once in 3 months, all OLTP data your data warehousing applications. So OLTP is one more database. It is, think as a small bucket, right? So what is OLAP, or what is, data warehousing is called OLAP. So you will create a bigger database. It is what is called again OLAP. So it is also called as what? Data warehousing. Okay. So you are going to be getting all the data from here to here. So once in a month, once in a week. So if you get, let us say, you're able to get January data now, February data will be coming. So April data, people are going to be getting the data. So what normally you do, you use ETL processing. You're going to be getting Jan, Feb, March data. So Jan data will come, Feb data will come, and March data will come, and April data also, over April data also, you got it. Now, so there is a rule. I supposed to maintain, let us say, 3 months data here, right? So already 4 months got over. You are in the May month now. What will happen? So 1 month data, people are going to be deleting here. Clear? What will March, April? Once April is over, May month data, you June you will start. So June month data will be here. So June is running. So when the June is started, what is the rule here? OLTP should maintain only 3 months data or 4 months data. So here, and June completes. So June data, you are going to be keeping it here. So this month the data will be deleted from the, OLTP application. So OLTP has to maintain current transactions plus at least 1 or 2 months or 3 to 4 months data. They're supposed to maintain it, right? Like that, every month you're going to be pushing the data to the data warehousing. Plus in OLTP, people are going to be deleting the data. Who's going to be deleting the data? SQL DBA guys. SQL DBA guys are going to be deleting the data. But before deleting the data, they are going to be taking a backup. So in case if something is missing, they can get it back. So SQL DBA team is going to be taking a backup of this database before deleting it, and they delete the one every 1 month data. They may maintain 6 months data according to the maintain lost 1 year of data, maintain lost 6 months of data, maintain lost 10 months of data, whatever be the reasons that have. So that is what. So OLTP size will not increase because we are going to be deleting, but OLAP size will be increasing because you should not be deleting any data. OLAP means data warehousing all the data. It will be, let us say, 2020 data. Like that you will be have 2021 data, 2022 data. Like that you are going to be having. So business may be started in, let us say, 2020 of January 10th the business is started, right? all the data it would have gone. So like that you need to understand. And all the data from 2020 till today, it will be there in the data warehousing. But in OLTP, last 3 months data or last 4 months data will be there. So you need OLAP. OLAP means online analytical processing. Clear? So here, so this is what is called normalization. So all the data bringing into small table is a normalization. But here you may use a single bigger table, but this is not possible. You may have two tables can be merged into one table, and these three tables can be merged into one more table. So these five tables in OLTP may become two tables in your OLAP. Clear? OLAP is going to be having, so it is not, it is transact it is historical data, no, not at all transactional data, historical data, read only data, right? And it is going to be having denormalized table. What is a denormalization? Normalization means splitting the data into multiple tables is called normalization, and combining these two tables data here and creating lesser tables into here. So this is what is called denormalization. I will give you a simple example. Initially, when I started my career, I was staying in a single PG, single room, one cupboard. All my items are kept in the single cupboard. So if I wanted to go to office, gym and everything, within 20-30 minutes, I'll take all laptop, shoe, and everything within cupboard. I will be able to ready within 20-30 minutes, because all items are available in single cupboard and single room. But after that 10 years, I got promotion, I got a bigger job, I have taken 4 bedroom flat. Now, what will happen? My items are distributed in 4 bedrooms. In one bedroom, I have a laptop. In hall, I have a shoe. In the third floor, I have a watch. In fourth floor, I have my specs. Like that, I have distributed all the items. Now, I want to go to the office. What I need to do? I need to go to the office, complete my shower. Then for the clothes, I need to go to, say room number 2 and get the clothes. For the belt, I may be keeping in room number 3. I go to room number 3. For the, car keys and everything, I kept it in the hall. I need to go to the car. So to get ready, I am visiting 4 places: bedroom number 1, bedroom number 2, bedroom number 3, bedroom number 4, hall. Then I'll go down. It is taking a lot of time for me. See, if you distribute the items clearly, that is okay. Storing wise, it is good. But retrieving wise, when you have placed data into multiple tables, it will be more late. So that is the reason what you decide. I don't need a 4 bedroom flat. I can also stay in single bedroom. I would like to go in for a 2 bedroom. So you're going to be denormalizing. Denormalizing means splitting data into multiple tables will create a lot of slowness for the reading. But writing will be very, very speed when you have a normalization. But as part of data warehouse, we don't write the data. Once in a moon, once in a write, we write the data. But remaining 29 days, we're going to be reading the data. So data warehousing always should read quickly. Okay. Reading means denormalization. Denormalization means reducing the data from multiple tables and keep into minimal tables. If we have 100 tables here, if you have 100 tables here, normally you may have 20-30 tables here. Clear? We are going to be using ERD technique here. Data dimension modeling technique we are going to be using for designing a concept. Right? Both of them you need to design. Used at the time of designing, and here normalization technique is used at the time of designing. Normalization means writing the data quickly. Denormalization means reading the data quickly, because you're going to be storing all 5 tables data into 2 tables. Now denormalization is reducing number of tables, right? Improving the redundancy, people will be calling this, but easier the layman the terminology is. So trying to arrange the data in small tables, and these tables are called dimensional tables and fact tables. Okay, data warehousing, the tables, data warehouse is also one more database only, according to EF called large database, read only database. It may be Oracle database, SQL Server database, historical data is going to be maintaining, dimension factor tables are going to be having, and more denormalized architecture. Clear? And business users are going to be connecting. So this is very, very important an interview question. You cannot run away. What is a OLTP? What is a data warehousing or OLAP? So data warehouse is a large database, stores historical data, stores large data, up to terabytes of data, stores denormalized data, stores read-only data, stores data in dimensional fact tables. It is also called as OLAP system, online analytical processing system, used to create reports and analyze the data from the data warehousing systems. This is also called as a decision-making system. To improve the business, we are going to be using data warehouse. But data warehouse, the positive points are it maintains asset properties and the data can be updated or inserted. Anything can be done here, right? Atomicity, consistency, isolation, durability. Clear? So, why RDBMS is more popular? RDBMS is more popular because of acid properties only. So, if you know SQL very well, what is acid properties? Atomicity, consistency, isolation, durability. So, it gives you proper quality to the business, proper quality to your data. For example, I have a data has to be always correct, always it must be in consistent state, right? And always it has to be protected, more security. All these are nothing but your code rules. Okay, we were talking about code rules, right? So whenever you store data into the RDBMS, it has to be always, it has to store the correct data, consistent data, and you should not be having a double entries, triple entries. So you need to implement locks and all. So lot many things internally it is going to be doing. Because of that, the data is always correct here. So RDBMS is not there to store the data. RDBMS is there to store correct data forever. So if somebody says we are maintaining data in RDBMS or SQL, means you can 100% you can give assurance that it is a cleaned data. But if somebody comes and says I am maintaining my data in CSV files, Excel files, you cannot guarantee, right? So if somebody stores data in SQL, that is 100% high quality data, correct data, because RDBMS engines, maybe Oracle SQL Server, is going to be maintaining acid properties. If you don't know what is acid properties, listen to the YouTube videos or listen to my classes, you will understand, right? But if somebody stores data in a files, right? Files means Excel file or a text file or CSV file. Do you give any guarantee for this data? So quality is a question here. Quality is always a question mark here. Remember. Clear? So normally files data, where are we going to store? All the files we are going to be storing today in your data lake. So what is the biggest problem with the data lake? That you can understand. Data lake is going to compromise your data with the quality. That is the biggest issue. People will ask, what is the biggest problem in the big data? Big data today, we are not storing in databases. Big data, we are going to be storing in either Azure Data Lake or a blob. So blob means files. What is the biggest problem? The quality is the biggest problem. The bad data, we are going to be getting large amount of bad data. That is the biggest problem in the big data, or maybe in Hadoop data, Spark data, because we do not know the quality. Why? Data comes from the files data. Nobody can guarantee. It has to be it may be having a lot of bad data. So people will ask you this question: what is the biggest issue with the big data or Hadoop with the Spark? Anything? The biggest problem with the big data is quality. Quality you cannot guarantee. So data lake does not have a acid properties. Data lake does not have a acid properties. And data lake data, however, we are updating the data here. So we cannot go to file. You cannot keep on updated data. That is also data lake cannot do that. Are you able to understand? So acid properties, you must know. Because of acid properties, what is the advantage here? The quality will be improved, but quality is compromised in the data lake, right? So data warehouse is going to be having acid properties and this one, but here updations you cannot do that. That is not there. Acid properties also not there in your data lake, right? So that is the quality compromise. You need to compromise the quality in the data lake if you store the data, right? So this was the data warehousing. So if you wanted to uh, get the data, for example, I'm talking about Amazon company wanted to have the data. So Amazon company is running their business in 100 locations, maybe in India, Dubai, Saudi, Japan, America, Europe, everywhere. So the data is not there in the single place. Amazon data is available in thousands of places. Now you cannot go and run your reporting here. You cannot go and run the reporting here. So what you need to do, all the Amazon data, it may be in Japan. The Japan data may be in SQL, it may be in Excel. So SAP may be Singapore data. All the Amazon data, what we need to do, we have to bring it. So with the help of SSIS, that's what we were using initially. All the data we have to keep it in the staging server. Staging means temporary server. So what you do, it is also hard. Where SQL is running, data cleaning is going to be happening here. So if we have a lot of duplicated data, all the data as it is, we're going to be dumping. Step number one. So this is a source system. From the source system, it is what is called as OLTP system is this. If you're buying a product, this is your laptop or this may be your phone. If you're buying a product, your data is going to be written here. You may be ordering the orders from here, it may be going here. All the data, whenever user is connected and doing any transaction, the transaction OLTP database of Amazon.com. Or you may be entering some data in Excel sheets, maybe SAP data also will be there in some Oracle database. End of the day, Oracle cannot store data. SAP cannot store your data. SAP will be using either Oracle or SQL databases only. So all this data once in a while, what normally we do with the help of SSIS, we are dumping into your staging area. Staging means temporary area. It is also database hardware with the SQL. Data cleansing we are going to be doing. So all the cleaning work we are going to be doing. After cleaning, we are again using this data and take this and dumping into your data warehouse. Clear? That's what. If it is maintaining Jan data, February data, March data, like that. Okay. April data, you're going to be getting all the data. But continuously, we cannot keep all the data. All the Jan data will come February, March, April, May, like that, you're going to be getting all the data. So, what is the rule? Always we need to maintain 3 months of a data. This month data will be there. This month data, they're going to be deleting it. If March, April, May, June is there. If the June is completed, so June data also you will get it here. This data also they're going to be deleting. Who's going to be deleting? SQL DB. Always 3 months data we need to maintain. Then July data comes. July also gets over. Then July data also they're going to be keeping it here. So April data will get deleted. So always you're able to maintain 3 months data. So OLTP most of the time refers to databases only. These databases are normalized and read and write databases and transactional databases, more speed and less data. 3 months data, maybe it may be less than 1 terabyte or less than half terabyte, 2 terabytes of data they may be having. Maybe OLTP databases will be in GBs, let me say 500 GB of all 3 months data. If you get next month data 1 or 2 months because of seasonality variations, Diwali is sales, you may be having 100 or 200 plus data. Sometimes it will be more. Clear? So like that, you need to keep in mind that. So OLTP databases are small in size. Once it is over, once in a month, once in a while, you're going to be taking the data from here, and all the data are going to be dumping into staging. You clean the data, clean the data again from this database. You're going to be taking this and dumping into a data warehouse. So data warehouse is called as OLAP. Now, using this data warehousing, that data warehousing will have a cleaned data. So, using that, we are going to be creating a lot of reports and visualizations. right? So storing, data warehousing, storing the data and creating reports, this entire system is called as actual OLAP system. OLAP system means what? Online analytical processing. These reports are going to be given to whom? To the end users to take the decisions. They will understand by seeing your report. So why the sales is less here, why the sales is more here, or if you have one, one graph comes here, these managers will be able to understand why the graph is showing that the sales is completely drastically down here. Right. So always we take the data every month. We're going to be cleaning and pushing it here. You may be getting the files data also. We are going to be cleaning and keeping it here. So data warehouse is a large database, and it's going to be having acid properties. So here also we are going to be having acid properties. Acid properties means you cannot have inconsistent data. You cannot have wrong data by creating a primary keys, foreign keys, check constraints, data modeling. Lot of techniques are implemented, and logs, lot of things are implemented as part of this. Make sure that your data is always correct. And if there is a wrong data, it will be able to identify very, very easily. So since data warehouse is also SQL database only, same acid properties at the OLTP side, OLAP side, it will be there. So always maintaining correct data. Clear? OLTP always will be right in good speed. You need to have in here. If you want to get good speed normalization, lot of tables are going to be small tables are going to be prepared here. The small tables will be merged back and create a few tables called as a denormalization. It has to give more and more read capability, and less joins you need to have it is distributed into DIMS and fine fact tables. Why data warehousing systems means to create a reports and analyze the data, and decision making systems. These are removing duplicates, common data modeling, everything you're going to be doing as part of your OLTP and OLAP. And this system, data warehouse stores up to this kind of a data. This is what is called as a business intelligence system, business intelligence architecture. So here we are not going to be implementing AI or BI here. You may implement BI, business intelligence means reporting. You can do it, but if you wanted to implement AI, artificial intelligence, you need more unstructured data or semi-structured data where AI is going to be working. So BI was more popular along with the data warehousing data. But slowly, what we're doing? So slowly, if you wanted to store big amount of data, data warehouse can only give you data warehousing data means structured data, or maybe SQL data. But if you wanted to work with the unstructured data, semi-structured data, where data warehouse is going to be failing, right? So that is where data lake is going to be introduced. So 1990 is warehousing system implemented in the worldwide, right? Data warehouse. It is also large database. Now, if you see in the next in 2010, 2011, this concept is implemented because especially big data is started. So big data means unstructured data. Most of the time you may have a structured data also, but most of the time unstructured data and semi-structured data. Semi-structured data means the data given by files, JSON files, or any log files. These data you're not going to be giving. Systems are generating this kind of data. This kind of data is more and more. So where to store the data? So data lake, where the system implemented to handle this. Structured data you can also have in your database or data warehouse. So that is the point. So we have from the structured data, BI is going to be happening, but unstructured data, semi-structured data, to implement this, we need to invent what is called as a data lake. So data lake is a cloud storage, stores data in the the cluster, multiple storages, store structured, semi-structured, but most of the time this is the data stores a large amount of data, petabytes, zettabyte, stored data in a file format, CSV, JSON, Excel, Parquet, ORC, or any image files, or any any data also. Right? Let me. So it may be having a lot of other data, right? Or audio, MP3, MP4. That means simply I can write audio file, right? Or video file, or any photos, pictures and everything. So this kind of a data, XML data, this data, that data, all these things can be stored. Only problem with ACID means, so no ACID properties, and the data cannot be updated here. That files data you cannot update, however you're updating every minute your RDBMS data. So data lake is going to be compromising the quality. That is the biggest issue. And more data today, not with the SQL data. So if you see the data, this is my data we're talking about. More and more data, structured here, unstructured and semi-structured data. There's only 20% of the data globally. 80% of the data, only your AI applications are going to be working perfectly fine. On this data, your BI applications are going to be working fine. Structured data means almost all the time you're going to be getting the data from the business. Clear? So that is the reason it is always says structured data means business intelligence. Right. So remember why business intelligence became so popular, because structured data most of the time is going to be coming from businesses only. So business intelligence means I need to take insights about the business with the help of a reports. So here we're going to be using Power BI or Excel reports. Any reports you can use it. So data analytics is also called as a BI, because we are working on the structured data. Right? So remember that. But most of the time, unstructured data will be handling. Unstructured data means going to be stored in the data lake. Quality you cannot guarantee here. Quality is always good here. So now what Databricks has done, Databricks has implemented one more concept called, so the concept is called Delta Lake. Clear? So that is the concept it is implemented. So, what is a delta lake? So, that is what is the question many people are going to be asking. It is data warehousing. Data warehouse will have more quality of the data because of acid properties. What's it acid properties? I'll tell you in a moment once again. So, data lake is going to be storing unstructured and semi-structured data and everything. Now, combining of these two, data lake and delta lake put together, we have a lake house architecture is implemented. It is also called as a delta lake or delta tables. So all the tables may be data coming from a data lake, or data may be coming from a table. All the data, if you store the data into the delta lake, what are the advantages here? All the acid properties are going to be implemented. Acid properties are going to be implementing the quality of the data will be more, right? More quality of the data can be implemented in the Delta Lake, but Data Lake does not have that. It is implemented in Databricks recently, invented in 2019 by Databricks community, and acid properties and data can be updated, and you can maintain lot many things. Now, we are not storing data into the data lakes purely. Now, Databricks is going to be storing all the data into the delta lake tables. If you see my medallion architecture, so where I'm storing delta tables means my data is going to have more acid properties are going to be implemented. What is acid properties? It is atomicity, consistency, isolation, durability. If it is not there, you will have inconsistent data. Inconsistent data everywhere. So that is very, very important. Let me give you a simple example. For example, I am maintaining some data in Excel sheet. Excel sheet is not a RDBMS, right? It is not SQL data. For example, I say customers data I'm going to be having, and they have taken, let us say, loans, and they're paying transactions data. So I take a customer. So I'll have customer ID, customer name, and what is the loan he has taken, loan number, and loan amount. Okay. And what is the amount he has taken? Blah, blah, blah. And what is the balance? Balance amount, I'm going to be having it. Customer number one, let us say John has taken some loan number 1233, has taken, let us say, some 10,000 rupees loan. As of now, the balance is 10,000 rupees. In the transactional table, I'm going to be writing the transactions. Clear? So I take this data. I'm going to be having, let us say, uh, what is the EMI paid date. So then EMI amount, like that, I'm going to be writing some data, right? So now I try to implement. So customer number one as paid, let us say 500 rupees or 1000 rupees is paid some date, okay? Is paid, let us say on December 10th and 2021, he paid some amount. So when you go here, first of all, you need to verify whether the existing customer is going to be paying or not. By default, by mistake, if you enter 11 year, by mistake you have entered in the 11 in your Excel sheet, do you think that Excel will question you? Hey Bhaskar, you have entered wrongly 11, but you don't have 11 here. Do you think that it will be asking? Excel will not ask. Why? Excel does not have a acid properties. What do you mean by acid properties? Atomicity, consistency, isolation, and durability. Excel is not that kind of a tool. Is not that kind of a tool. It cannot maintain. It cannot see also. So this is one thing. How do you do this? By creating a primary key and a foreign key. When you're creating a primary key and foreign key, when you enter wrong number here, this number SQL engine is going to be taking and going and verifying. Is it 11? No, 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 no. This data will be deleted by RDBMS. So this is going to be happening automatically because of there is a small piece of code that is running. The piece of code is called acid engine. Clear? So atomicity, consistency, isolation, durability. Remember like that. Okay, this is one example I wanted to give. Let me give you one more example. So you have some bank account number. Your account number is something. Your name of this one. What is the current balance in your account? Let me take a banking example also. So why RDBMS is more popular? Not to store your data, to store correct data. Your account number is 1234. Your name is Bhaskar, right? So I wanted to say currently I'm having 10,000 rupees. Now one more number, let us say John, and is having 12,000 rupees. Like one more customer, let us say Krishna, is going to be having 1,000 rupees in his account. This is account. It is a accounts table of a bank. Now I go, there is a bank transactions. Okay. So it is transactions in the bank. So what kind of a transactions we have? So we'll have a transaction number, automatic number it is. And what is the account ID? What is account ID and the date of transaction is doing, and what is the transaction amount, and what is the type of the transaction, right? This is the data I'm going to be maintaining in a, let us say, SQL table, or maybe in your Excel table. Now, let me give you what is the issue. You have two people. Bhaskar is sending, let us say, 1,000 rupees. So, account number 1234 is depositing cash or transfer, transfer funds. So, from which account to transfer? From 1234, what is the amount? So, let us say 1,000 rupees I wanted to transfer from my account to, let us say, this account. This is the second account number. So transfer means, so here cash withdrawal has to happen. Here cash deposit has to happen because 1,000 rupees I'm transferring. Clear? So what will happen when you transfer the funds? your account 1234 is going to be some numbers, continuous numbers will be there. Your account ID will be Control C, Control V. Your transaction date, for example, say December 21st, 2021, you have done this 1,000 rupees. Transaction type is cash withdrawal has to happen when you transfer the funds using a phone pay account, anything. You can use phone pay or Google Pay. So phone pay will remove 1,000 rupees. It has to come and you need to have 9,000 rupees here. That is fine. So you have done it. Then immediately in this Krishna's account, there has to be one more entry. Krishna's amount on the same day, it has to be same entry, it is cash deposit. It is done, then it has to go and it has to be 2,000 rupees. Now tell me, if I am doing this transaction, this is entered. Clear, transfer is done. You have successfully deposited the amount. So it is going to be inserting one row here, but during insertion of this row, current is failed. No power. Power supply is gone. When the power supply is gone, what will happen? This entry will not come here. Even this guy will be having the same thing, but here there's a deduction is happened. Okay, 1,000 rupees you're transferring, the 1,000 rupees deduction is happened here. Then the next transaction did not happen because it is not your problem, my problem. It is a power problem. So it is not Bill Gates problem, Microsoft problem, no problem, right? If you're maintaining data in Excel sheet, if you forgot, if the power goes off, no data, no consistency is going to be maintained, right? Because you have removed the amount there, you have written one line here. After that, the power has gone and you forgot to enter manually. If you're maintaining like this in Excel will have a lot of issues. So this data you're not going to be maintaining in Excel. You assume you're using RDBMS only. In RDBMS also there is a power failure. What happens now? So because of atomicity, acid properties, clear, acid properties, atomicity, consistency, isolation, durability. Because of these properties, this piece of code is running. This code, when you switch on the system, it is going to be verifying any transaction is going or not. How do you know? So RDBMS engine is going to be maintaining data one side. This is data. The other side, it is going to be maintaining a log file. Okay, so this is SQL is going to be maintaining. So this asset properties engine will come and see what are the transactions currently happening. Transaction means this transaction is have happening. This step is over. That means this is happen, and in this position, this is a failure. It can see whenever you try to do any transaction. For example, you wanted to transfer some funds. Immediately, the request will go to RDBMS engine. RDBMS will not do anything to the data first. It will be writing a step in the log file saying that this is what we're going to be doing. It will write, I wanted to, withdraw some cash in the this so and so table. It is going to be writing that step and deleting it. The second one, I wanted to perform the second operation. What is second operation? Add that amount into second table. Like that, it is going to be writing all the steps, and it is going to be also saying it is done. It is done. It is there is a failure, right? So when you restart the system, this atomicity engine will come, will verify what are the active transactions are happening. So this transaction is one, step number one is done, step number two did not happen. So it will come to this transaction number. It will say, okay, this is done, and because of that, consistency would have been done. So what will it will do? Either it will complete the remaining steps, it will add one more row here, and it will go and update this balance also. Or what it will do, it will go and go back and roll back the transaction. That means without you are doing nothing, whatever already done, it will be, so this will be deleted from here. This will come back and it is going to be keeping the amount as 10,000 rupees. Yeah, clear. Who's going to be doing? You're not going to be doing. So there is a process called atomicity, consistency, isolation, durability. It is a piece of code monitor internally. Clear? All the transactions are smoothly happening. Everything is doing, all the steps are not. Because transferring a fund is not one step. You have to cut the amount in your table, my balance, and I need to get one SMS, and my balance, your balance also should change. Lot of things have to happen. So all these things can happen because of one guy. The guy is called atomicity, consistency, isolation, durability. This piece of code is going to be running internally to your SQL tables or SQL RDBMS, maybe OLTP databases or data warehousing database. Because of that, your data will be always super duper and high quality. But this kind of a data, if you maintain in Excel files or PDF files, that kind of a checkingness, that kind of a quality will not be maintained, because human beings have to maintain everything. The machines will not maintain. Machines are going to be maintaining because of acid properties. So this kind of a checking now is implemented now when the Delta Lake. So Delta Lake is going to be also questioning, hey, what is this? What is that? Right? So normally what will happen, you're going to be dumping the data from here to here, right? If you have 1 2 3 data, you have dumped only 1 and 2 remaining, the job is failed, you did not get the data, right? So what will happen, or one job is working on some data, the job is failed in between. So it has copied only one, it has copied, the job has copied only 2 rows here. So job is failed. And when you come out of that, nobody's, will see whether the copy is completely happened or not, whether the copy is completely happened or not. Who's going to be worried? Earlier, nobody were worried. Nobody was worried. But today, Delta Lake is going to be worrying. Hey, the job did not complete to copy the data. The job is also failed. So Delta Lake will maintain asset properties. If anything, any mismatch happens, immediately either roll back. Roll back means delete all the data, whatever we have copied, and you push the back. Otherwise, what will happen? You copied 1 and 2, and when the job again runs, again you copy 1 and 2, and you copy 3 also. It will create duplicated data. Because of lot of job failures, slowly you create a big mess here, because nobody is monitoring. But today, Delta Lake asset properties are going to be maintaining everything smooth. It is automatic program. Somebody is going to be taking a stick and monitoring strictly. If somebody is failing, that guy should not come and copy the same data, or we should not keep the data like this also. So you have done, job is failed, after that nobody is taking care. See, 1 or 2 rows means manually we can do that. If you have millions of data, which row is copied, which row did not copied, how do you know? So somebody has to keep the eye. So whatever jobs are failing, then whenever you restart the computer, everything need to be there in either zero state or complete state. Either get all the data or delete all the data, but you should not complete half done works. All of them can be maintained with the help of a Delta Lake. That is the beauty of it. So it is implemented by 21. So Delta Lake is going to be having a lake house, Delta tables, lake house tables. So we're going to be continuing further tomorrow. If you have any question, you can ask me. So what is the data lake? I have spoken about it. What is Delta Lake also? I have clearly told you. If you have any doubts, you can ask me now. It is a cloud storage, stores data in a cluster, data lake and source data. All of them we have discussed, right? What is data lake? We have discussed. What is Delta Lake? Also we have discussed. What is a data warehousing? Also we have discussed. And what is OLTP? What is OLAP? Also have discussed. If you have any questions, you are welcome. Will continue further. All the silver tables, all the delta tables, now we are going to be storing as part of Databricks. Databricks is going to be having data lake or lake house concept. So it is going to be implementing what asset properties to maintain the correctness of the data. Are you clear? Any questions? You are welcome.